But Zubin, why is reading code so hard and is it really that important?
Absolutely. For most of your life as a coder, it's more important than writing code.
So 76% of people spend more time reading than writing code. And this is kind of common sense when you think about it, because most of your work will end up reading other people's code. And we'll talk about why that is.
Welcome to Easier Said Than Done with me, Zubin Pratap, where I share with you the tens of thousands of dollars worth of self-development that I did on my journey from 37-year-old lawyer to professional software engineer. The goal of this podcast is to show you how to actually do those things that are easier said than done.
Hey guys, this is Zubin again, and today I wanted to talk to you about why reading code is so much harder than writing code, and why reading code is at least as important, if not more important, than actually writing code. Now, the reason and the context for this is a post I did on LinkedIn. I'll show you that in a little bit. But the reason and context really is most of us spend most of our time when learning. We spend all our time really learning to write code. Okay, whether it's computer science school, boot camps, learning online, whatever program you take, it's all about the writing of the code. Okay, and it kind of makes sense because in traditional education, we tend to write the alphabet along the time that we're trying to read it, but we spend a lot more time practicing the writing, right? Which is why a lot of people are better at writing than they are at reading books, for example. Now, the same thing happens, I believe, in computer science and software engineering, but it's a very big problem. But first, let me switch over to my screen share and show you this LinkedIn post that gives you some context. So this is about a year ago. And my question was, engineers with more than 1 year's experience, do you spend more time reading or writing code, right? And 76%, the vast majority said they spend more time reading, and it's 112 votes, right? Before it closed. So that's not a trivial number. Of course, it's not a huge number either, but it's pretty representative, right? So 76% of people spend more time reading than writing code. And this is kind of common sense when you think about it, because most of your work will end up reading other people's code, and we'll talk about why that is, and I'll give you more of a perspective of that in a moment. But let's talk about why it's actually harder to read than to write, right? Well, the first and foremost is when you're reading other people's code, because code tends to be more terse, in other words, more minimalistic, because a compiler will work with minimalistic instructions. In fact, that's probably better for the compiler, you could argue. And so a lot of context is lost, right? A lot of context is missing. And it's really hard to figure out somebody else's thought process and logic. Now, think about this in real life. It's really hard to figure out somebody else's thought process and logic sometimes when you're driving, or when you observe another friend's behavior, or you see people doing crazy things, right? Like it's hard to understand another person's thought process or logic. We often complain this about the government too, right? Why are they doing this? It makes no sense. That's true of traditional human language. This is true of human behavior, and it's 100% true in coding, because we lose a lot of the context. We don't know the background and context as to why this is written, and that makes it really, really hard. The next reason is, obviously, when you're not familiar with the code base, it's going to get really hard to understand it, or it's going to feel very complicated at first. Now, here's a way to understand that. The human brain works a lot with familiarity. The more familiar things get, whether it's your route to work, whether it's, hey, here's an example. When you go to an Airbnb or somebody else's place and you've never been there before, you may know exactly how to use a fork and a knife, and you may know how to use a toaster and a microwave and the stove and an air conditioner. But when you go to somebody else's place, you have no idea where all these things are. You don't know where to find them. You don't know where to look them. You got to hunt around and explore, right? Exactly the same with code. You have to hunt around and explore to find, hey, where is everything written? Where is everything kept? How does all of this work together? What's the process to be followed in this particular environment? House, right? Code base. So lack of familiarity with the code base makes it very hard. And finally, it's scary and it's time consuming, and it's a lot less fun than making a button jiggle or something like that, right? So it's therefore something we tend to avoid. That's what makes it so hard. Now, the other thing to consider is, well, why is it so important? Why is it so important that we learn to read code? Well, first and foremost, you can't avoid it. So, and we'll talk about that, why in that section here, why we can't avoid it. But the second thing is, you actually really need it to debug. Okay, you really need to be able to read code to debug. Why? Because the code that you write imports a lot of other software. Look at all the imports on the top of the file, and go and take a look at their open source, if it's open source, and see just how much code there is, right? So your code is going to import way more software than you've written, possibly more than you've ever written, right? And so you can't debug without knowing how to read all this code when you need to, because sometimes, and actually quite often, documentation is not going to be up to date, or sometimes documentation will be downright wrong. And the more senior you get as an engineer, the more you'll start going to the original source code to figure out what's going on, right? This is an unfortunate state of the world. It's easier to write code than it is to write documentation, because think about it. It's so much easier to write, say minimal text than it is to write a proper coherent paragraph or a letter or a sales memo or something, right? So documenting for different audiences is very hard. So we just need to accept that in some senses, reading code will probably give us more of an answer than some documentation that's not maintained well could, right? And that's a reality of software engineering. Now, another reason why reading code is really important is when you're importing other packages, that code becomes part of your code, which means their bugs become your bugs, right? Now, your customer doesn't care whose bug it is. They don't care who introduced the bug, whether, it was the creator of Ruby on Rails or, Linux or the Golang authors. They don't care. Your customer only knows that they had a rubbish experience because of your bug, okay? So their bug, your imported code bug, becomes your bug. So debugging is super important because it's going to impact your customer, right? And now it's your problem regardless of how it got into your code base. And that's the nature of having an ownership mentality when it comes to your code. So that's why, reading code is really, really important. And finally, this is a little bit harder to necessarily accept when you're struggling with code when you're reading it. But the reality is, in hindsight, you'll realize that you learned a lot and you got a lot of good new ideas. You learned about coding patterns and you've learned about all the gotchas that come with designing code. Now, the reality is, code that's mature and stable got that way through a lot of battle testing, right? And battle tested code can be hard to read because they've got a lot of edge cases. They've found a lot of logic errors or runtime errors, all kinds of issues have come up. Business logic issues, right? And it may not be clear to you why that's there because there's so much history that's gone into a mature code base that you will never get to see. So you tend to need to accept code bases as being probably smarter than you think it is, and certainly smarter than you are in that moment. Okay, now coming to the point about why we can't avoid it. Well, guys, think about it. The reality of the workplace is that most of us will end up working for an organization that's not a complete greenfield startup. What do I mean by that? We're not going to walk into a job and write the first line of code for that company. It's extremely rare that happens. Most of us, when we get employed as software engineers, go into a company that's had at least a few 100,000 lines of code already written, most of the time, right? The vast majority of the time. And if you're working for a company that's been around for more than 10 years, we've got millions of lines of code that got written before us. And if you're fairly young, in your 20s perhaps, you may join a company that's been around since the 80s or the 90s, and some of that code may have been written before you were born. The reality is the workplace is not about writing new code. Okay, when you walk into a place, the workplace is about understanding the code that's already been written so that eventually you can add to it in a safe, production-ready, meaningful way. So the reality of the workplace is there's a lot of code that was written before you got there, and you're going to know how to read it so that you understand how to do it. This is why, by the way, for example, when I was at Google, they give you quite a lot of ramp up time. There's Google-specific tools that you won't see outside in the rest of the world. Their habits and practices and workplace practices and code review policies. I mean, they don't even use GitHub in most of Google. They don't use VS Code in most of Google. They have their own IDE, their own code base. It's the world's largest monorepo. You can look it up online. All the development's done in the cloud because it's too big for most machines to run the code and build it and all the rest of that. So, it's a whole different world. And so when you get there, you realize, gosh, most of the stuff I'll be doing is understanding how all of this works, which means reading code becomes really important. So what are the skills you need to have in order to become good at reading code? Well, number one, patience, because it takes time. It's frustrating as all get out. It's hard. And a lot of it is just confusing, right? So you need to have patience. Then you need to have a solid process. And this comes with a bit of trial and error based on your own temperament. So knowing yourself is really important, right? What works for me, for example, is starting really small and then following an input, usually that I got to know of because of a bug. So, I follow the input. All right, what data went into this function? I look at the stack trace, right? This is where this seems to have started and then bubbled up. What data went in there, right? How can I look at that data? And as it went through the system, because really all software application is data moving through the system, through the code base, data is moving, being transformed, being retrieved, being augmented, being deleted, whatever, right? It's basically data moving through the code. And so when I follow the code base, when I follow the input all the way to try and find to the output that, produced the bug, for example, well, that's my process. I just follow the one thing. I don't get too distracted. The best way to do that is to use IDE tools and shortcuts, code navigation in your IDE, searching for what's known as symbols, look that up if you don't know what that means. It's a much faster way than just doing the text search, is to look for the symbols. And of course, when it comes to a point where, the few logging statements, console log or whatever it is, doesn't work anymore for you, or it's too many nested function calls, for those of you who are new to code, that may not make a lot of sense. But sometimes, basically what it is when you're calling libraries, for example, you could be calling dozens of functions. The data could be going through dozens of functions that, call each other, and you have to sort of drill through that, right? So sometimes the best way to do that is to learn how to use your debugger. Often the inbuilt debugger in something like VS Code is very helpful, or whatever tool you're using, you'll often have, modern tools will have an inbuilt debugger. And when I say modern tools, I'm talking about the last 20, 30 years, so it's not like it has to be from 2018 or something, okay? And so you learn to use those tools, learn to search through and investigate the code base, and we'll talk about the sort of mindset you want to have for that. Oh, what's happened here? Oh, I know what's happened here. There you go. That's better. So that's what we want to do. And you want to be able to also assume a good reason or intention in the code, even if you don't see it. So you may be frustrated. You may think this code was an idiot. This is not how I would have written. Very common response. You're probably wrong. They're probably smarter than you are in that moment because they know more context, know more history, have seen the actual problems arise. And so you want to assume there's a good reason, even if you cannot figure it out and you do not agree with it. Chances are you're wrong. You just don't realize it, right? So that's why it's important to keep a really open mind, especially when you're convinced you have a better approach and you would have done it differently. Chances are there's a reason they tried that other different approach that you're thinking about and it didn't work, and you just don't know about that. When the code's actually written, you lose all that history. You could look at it in the Git commit history, but hey, you could go back years, right? So the biggest skill I would say is to reframe what you're doing when you're reading code. When you're reading code, you're not programming. Okay, it's a part of the programming process, but you're not programming, you're not writing, so you move away from a programmer mindset or frame, and you put a forensic detective mindset, frame, or lens on, okay? You stop being a code writer for a moment, and you're like, I'm an investigator. I'm a detective. I need to dig in and find the clues and solve this problem. Okay, so it's not about writing code. It's not about being, a fancy hacker. At this point in time, you're just a researcher or a detective. Okay, so look, I hope this was useful. Some of the useful resources that I recommend are, I think, Trisha McGee's, sort of presentation on this. I think there's a YouTube talk on it as well. And then definitely the Pragmatic Programmer book. Look, it's a really good generalist book. I think topic 20 or 22 or something is on debugging, and there's another topic on tracing. So, useful skills. It's a kind of book that you don't have to read from cover to cover, from left to right in one sitting. You can dip into the chapter. So pick this book up and keep dipping into it. It's got really great distilled common sense. Okay, hope that was helpful, guys, and I'll see you next time.
Do it. Just subscribe. You know you got to do it.